So the last thing I want you to do now is, or we're going to do, is just practice. The first slide we did, we looked at a picture and we went into equations. Now I want to go from words to a picture. In this case, it says write the diagram for a cell. So this is like a galvanic cell with a hydrogen electrode on the left, which would be the anode, and an iron 3, iron 2 electrode on the right. That would be the cathode. The two electrode compartments are connected by a salt bridge. Okay, so given those words, I know I'm going to have two physically separated compartments. I know I'm going to have a salt bridge connecting the two. Okay, I'm going to have some liquid for the ions to move around in. On the left-hand side, it's called a hydrogen electrode. Now, what's a hydrogen electrode? I know that this is going to be the anode, the site for oxidation. And for hydrogen, what does hydrogen look like when it's oxidized? We actually looked at the hydrogen oxidation half reaction in the last lecture. Hydrogen, if it's oxidized, it's going to give up electrons, and it's going to give the cation the hydrogen. And we saw that we had to balance it both in mass and charge. And so now hydrogen is a gas, and this is aqueous. So how do I have a piece of metal that's going to act as the anode? Well, a lot of times what happens is we have what's called an inert electrode, just something that can conduct electricity but doesn't participate. For example, a common one would be like a graphite electrode or a platinum. So we'll just use platinum here. A piece of platinum is going to be immersed in this solution, and there's going to be a wire attached to it. This is going to be the anode, so it's going to be where it's a negative, where the electrons are produced. I have a little voltmeter here, so some voltage is going to be, a load is going to be applied across this. Okay. I know this is going to be the cathode, the positive side. So have I worked this out yet? Not quite. How do I get hydrogen in there? Well, just think about it. You're going to have hydrogen as a gas. There's probably some kind of a tank over here, and you're just going to put a tube on it, and there's going to be some kind of adapter around this electrode where I can blow or bubble hydrogen around this surface. So the hydrogen, and this is hard to see, someone right over here, the hydrogen gas is going to be bubbled through this tube here around this electrode. Those are bubbles of hydrogen gas. Okay? Hydrogen gas. These are little bubbles of it. Okay? And what's going to happen at the surface then is you're going to have a solution here with some hydrogen ion in it. Maybe you've got some chloride anion, maybe it's hydrochloric acid solution or something, and the hydrogen ion is moving all around. At the site of the at the side of the electrode, the hydrogen is going to give up its electrons, and it's going to turn into the hydrogen ion. Okay, so on this surface, so we call this the anode, and it's right on the surface where this is going to happen. There's already some acid in solution, there's some hydrogen gas being bubbled in, there's water and whatnot. Okay, and then the electrons are going to move through the wire, through the circuit this way. What about over here? We have iron 3 and iron 2. So iron 3 and iron 2, those are both ions, so those are both going to be in solution over here. So what could be going on? If this is the oxidation, then what's going on over here? We must have reduction. And so that must be the iron 3 plus is being reduced to iron 2 plus at the surface of this electrode. Let's just make this one platinum also. And so what's going to happen is the electrons are going to be making their way across the wire and down here. And when an iron 3 plus ion comes near this surface, it's going to pick up one of those electrons, and it's going to be converted into iron 2 plus. Okay? And so that's going to be a reduction, a gain of electrons. So this is the half reaction that's going on here. This is the half reaction that's going on there. So you can see, given an oxidation half reaction and a reduction half reaction, you can think about a way to design a cell such that you can separate the two half reactions, and you can push the electrons around an external circuit such that they can do some work for you, whatever that may be. All right, light a light bulb, run a battery, whatever. Excuse me, run a radio, whatever. All right, so you know, I don't necessarily think that you guys could have come up with that on your own necessarily, but this is what chemists do and engineers. They think about what they have, what they know is a spontaneous change. If I put hydrogen gas with iron 3 plus together, there's going to be a spontaneous redox reaction. How can I separate the two to harvest it? And that's what a lot of research is, engineering research or product development type research in this field. Okay, here's one more. Write a diagram for a cell that has an electrode consisting of a manganese wire dipping into a solution of manganese 2 ions on the left, a salt bridge, and a copper 2, copper 1 electrode on the right with a platinum wire. Okay, so what I want you guys to do is just brainstorm around this and see if you can figure out, given these two reactions, I'll give you a hint, that's the oxidation reaction, and see if you can draw your own electrochemical cell given this information, such that if you were on a desert island and all you had were manganese wire and a copper to a solution, how could you fabricate yourself a little bit of electrical energy to get your two-way radio running again?